Okay, students, last class we have discussed quick run of waves. So now I am discuss some questions based on waves concept. Okay, so first question is see, the equation y is equal to 4 sin pi into 200t minus x by 25 represented a transverse wave that travels in a stretched wire where x and y are x comma y are in centimeters, t in seconds. Its wavelength and velocity are. So wavelength is how much? Velocity is how much? You should find out. So here given equation y is equal to 4 sin pi is taken inside the bracket, that is equal to 200 pi t minus pi by 25x. So comparing this equation y is equal to a sin omega t minus kx. So here omega is equal to how much? 200 pi. So k is equal to how much? Pi by 2 pi. So we know that velocity of the wave v is equal to omega by k, that is equal to 200 by pi divided by pi by 25. So pi get cancelled. So that is equal to 25 into 50. 50 0. So that is a centimeter per second, because of x and y are measured in centimeters, but answers is given in terms of meters. So velocity v is equal to 50 into 10 square. Centimeter can be write down 10 power minus 2 meter per second. This one cancels. So velocity of the wave is equal to 50 meter per second. This is the velocity. So next wavelength, we know that k is equal to 2 pi by lambda. We know that k is equal to 2 pi by lambda. Here k is equal to how much? Pi by 25 is equal to 2 pi by lambda. Pi get cancelled, lambda is equal to 50 centimeters. But answer is given in terms of meters. Lambda is equal to 0.5 meters. Here 1 centimeter is equal to 10 power minus 2 meters. Okay? Okay? So here we should find out velocity of the wave is equal to 50 meter per second. So wavelength lambda is equal to 0.5 meters. Suppose the answer is given centimeters. Wavelength is 50 centimeters. Velocity is 5000 centimeter per second. Okay? Next question number 2. A transverse wave is described by equation y is equal to y naught sine of 2 pi ft minus x by lambda. Ft minus x by lambda. The maximum particle velocity is equal to 4 times of wave velocity. So maximum particle velocity, V max particle velocity is equal to 4 times of velocity of the wave, V of wave. So we know that in SHM the maximum particle velocity at mean position V max is equal to A omega, that is equal to 4 times of velocity of wave is equal to omega by k. Okay. So here given equation y is equal to y naught sine of 2 pi ft minus 2 pi by lambda into x. Okay, so this can be comparing equation y is equal to a sin omega t minus kx. So here amplitude A is equal to how much? Y naught. Omega is equal to how much? 2 pi f. K is equal to how much? 2 pi by lambda. 2 pi by lambda. Now substitute. So from now this equation. So A omega is equal to 4 into omega by k. Omega get cancelled. Here A is equal to how much? Y naught. 4 into k is equal to how much? 1 by 2 pi by lambda. So that is equal to y naught is equal to 4 lambda by 2 pi. 1, 2, 2 get cancelled. So from this lambda is equal to y naught pi by 2. Lambda is equal to y naught pi by 2. Second option is correct. Okay, now here we know that maximum particle velocity. So at that time only we are doing the problem. Sometimes maximum particle velocity 2 times or 1 by 2. So like that question is given. Any question is given, we can follow the concept or process. A omega is equal to 4 into omega by k. Substitute all the values. Lambda is equal to y naught pi by 2. So this is the second question. Next, third question. So two simple harmonic motions are represented by equation y1 is equal to 0.1 sine of 100 pi t plus pi by 3 and y2 is equal to 0.1 cos of pi t. Cos of pi t. The phase difference of the velocity of the particle 1 with respect to velocity of the particle 2 is with respect to velocity of the particle 2 at 0 2 at t is equal to 0 is. So here this is the displacement equations is given. We are finding velocities. So the rate of change of displacement is nothing but velocity. This can be write down dy1 by dt is equal to v1, that is equal to 0.1 differentiation of sin theta is equal to cos theta cos of 100 pi t plus pi by 3 into 100 pi because of 100 pi t. This one is also once again differentiation. Okay. Next second one, dy2 by dt is equal to, so 0.1 differentiation of cos theta is minus sin theta into here omega t, like once again pi. So that is equal to v2. So v2 is equal to minus 0.1 pi into sin pi t. So like here v1 is equal to 100. Here this one cancel. So 10 pi into cos of 100 pi t plus pi by 3. So here first one is the cos function, first velocity of the particle cos function, second velocity of the particle sin function. Okay, sin function. So now any one is changes. Okay, so here can write down 0.1 sine of sine changes into minus cos. Cos. So here both are write down same function. So either sine or cos. So first particle is cos function. So second particle is also write down cos function. So 0.1 pi cos of 90 plus theta. Cos of 90 plus theta. That is nothing but theta is nothing but pi. So cos 90 plus theta is second coordinate. Second coordinate cos is negative. So here V2 is equal to 0.15 pi t plus pi by 2. Pi t plus pi by 2. So phase difference delta pi is equal to first particle with respect to second particle. Pi by 3 minus pi by 2. So that is equal to LCM is 6. So 2 pi minus 3 pi. So that is equal to minus pi by 6. That is the phase difference. 1 with respect to 2. Suppose 2 with respect to 1 means pi 2 minus 2. So pi 2 minus pi 1. Here pi 1 minus pi 2. So here phase is pi by 3. Here phase is pi by 2. Okay na? Very important. Two equations is given. Both are taken into one function, either sine or cos. Next question number 4. If a Young's modulus of a material of a rod is y and density is rho, the time taken by a sound wave to travel L length from bottom is so time t is equal to, here is given Young's modulus of material of a rod, one rod is given, the Young's modulus is y, density rho. So the time taken by sound wave to travel L length from bottom. This is the length, L length travel from bottom. L length from bottom. So time is equal to, time t is equal to distance by, time t is equal to distance by speed. Distance by speed. So that is equal to, so time t is equal to distance is L, speed is so under root of y by rho. So we know that speed of the solids. So t is equal to L by under root of y by rho. So at that time t is equal to L into under root of rho by y. Rho by y. So this is the, so the time taken by a sound wave to travel L length from bottom. L length from bottom. So time t is equal to L into under root of rho by y. So here a solid is given, speed of the sound v is equal to under root of y by rho. Suppose liquid, any liquid is given under root of bulk modulus by density. Okay. Next question number 5. The extension in a string obeys Hooke's law is x. So that means V1 is equal to x. The speed of sound in a structured string is v. So V1 is equal to v. If the extension in the string is increases to, so E2 is equal to 1.5x. The speed of the sound will be is how much? Speed of the sound will be how much? So we know that the speed v is equal to under root of y by rho. So here in terms of elongation we know that Young's modulus y is equal to under root of, speed of the wave v is equal to under root of t by mu. T by mu. So here Young's modulus y is equal to FL by A. So F is equal to YAE by L. So here F is nothing but force, in strings F is nothing but tension, that is equal to YAE by L. So velocity V is equal to under root of YAE by L into, so linear density can be write down M by L. This L get cancelled. So velocity V is equal to, velocity wave in transfer stress, V is equal to under root of YAE by, mass can be write down volume into density. Volume can be write down area into length into density D. Area get cancelled. Here YE, L, D are constant. Velocity is inversely, velocity is directly proportional to under root of elongation. So at that time V1 by V2 is equal to under root of E1 by E2. So V1 is nothing but V2 you don't know, find out. E1 is X, E2 is 1.5x whole root. XX get cancelled. So V2 is equal to under root of 1.5 into V. Under root of 1.5 is nothing but 1.22 V. If it is any difference is given, different rods is given, Y is also different. Density is also different. Like, okay. Next question number 6. The equation y is equal to 5 sin pi x by 25 cos of 450t, cos of 450t. Represented the stationary wave set up in a vibrating sonometer where x and y are centimeters, x and y are cm, centimeter, and t in seconds, and t in seconds. The distance of second and third nodes from one and r. The distance of second and third nodes from one and r. This is one end. Stationary waves form like this. Okay, this is one end. This is the first node. So this is the second node. What is the distance from here to here? What is the distance from here to here? You should find out. Okay. So this can be considered lambda L1. This can be considered L2. Okay. So here given question y is equal to 5 sin. So 5x by 25 cos 450t. Here sin of 5x by 2 pi is indicates amplitude. So cos of 450t is indicates phase. So nodes and antinodes are depends upon position of a particle. So comparing this equation, y is equal to a sin kx, 2a sin kx cos of omega t. So kx is equal to pi x by 25. Kx is equal to pi x by 25. Xx get cancelled. So k is equal to 2 pi by lambda is equal to pi by 25. Pi get cancelled. So lambda is equal to 50 centimeters. Lambda is equal to 50 centimeters. Okay, so answer is also given centimeters. So we know that the distance between node and node is how much? L1 is equal to lambda by 2. That is equal to 50 by 2. That is equal to 25 centimeters. Like the distance between node, one end of the node and second node. So L2 is equal to lambda by 2 plus lambda by 2. that is equal to 2 lambda by 2. 2 get cancelled. So L2 is equal to lambda, that is equal to 50 centimeter. Second node is formed at 25 centimeter. Third node is formed at 50 centimeter. So answer is 25 centimeter comma 50 centimeters. Okay. Next question number 7. See. The fundamental frequency of a structured string with a weight of 9 kg is 289 edges. The weight required to produce its octave. Octave means double the frequency. Here how much mass is attached? 9 kg. One end is rigid support, another end is that wire is passing through a pulley like this. So weight is nothing but a tension, that is equal to 9G is equal to T. So T1 is equal to 9. So at that time F1 is equal to how much frequency? 289 edges. So you can ask the weight required to produce its octave. Octave means frequency F2 is equal to 2 times of F1. 2 times of F1. Okay. So here we know that fundamental frequency F is equal to 1 by TL into under root of T by m. So length does not change, the linear density also does not change. So frequency is directly proportional to root T. So here F2 by F1 is equal to under root of T2 by T1. So T2 nothing but M2G, T1 nothing but M1G. So that is equal to F2 is equal to how much? 2 times of 289 divided by 289 is equal to under root of M2G divided by M1 is equal to how much? 9G. So this one cancel. So this one cancel. So that is equal to squaring on both sides. So 4 is equal to M2 by 9. So M2 is equal to 36 kg. So you can ask weight. Weight is nothing but 36 kg weight. So answer is 36 kg weight. Okay. Next question number 8. Question number 8. The ratio of speed of sound in nitrogen gas to that in helium gas at 300 Kelvin is, assuming that both the gases to be ideal. Okay, both the gases are ideal. So here temperature remains constant. We know that velocity of sound V is equal to under root of gamma RT by M. So both the gases are ideal means gamma is same, universal gas constant R is same, temperature is also same. So velocity of sound is inversely proportional to under root of molecular weight. So here first one is nitrogen. V nitrogen by V helium. So that is equal to under root of M2 by M1. That is equal to helium is how much? Molecular weight 4. Nitrogen is how much? 28. N2. So that is equal to 1 by 7. So that is equal to speed of nitrogen divided by speed of helium is equal to 1 by root 7. 1 by root 7. Okay. Next question number 9. See, a closed organ pipe is vibrating in two overtones and is in resonance. Resonance means frequency state. With another open organ pipe vibrating in third harmonic. The ratio of lengths of the pipes respectively. First one is closed pipe. First one is a closed pipe. First overtone. In closed pipe, first overtone. Closed pipe, first overtone is nothing but a third harmonic. First overtone is nothing but a third harmonic. Like this. Third harmonic. So third harmonic F3 is equal to 3 into V by 4 LC because of closed pipe. Next, vibrating in with another open organ pipe vibrating third harmonic. Open pipe. Like this. So third harmonic open pipe F3 is equal to 3V by 2 L0 open pipe. This is the length of the open pipe. This is the length of the closed pipe. So here both are resonance. Resonance means this is closed. This is open. So F3 of C is equal to F3 of closed. F3 of closed is equal to F3 of open. That is equal to 3V by 4LC is equal to 3V by 2L0. 3V get cancelled. 2 1 2 2 So you can ask question the ratio of length of the pipes respectively. That means closed by open. So that is equal to LC by L0 is equal to 1 by 2. LC by L0 is equal to 1 by 2. Next question number 10. Question number 10. The open pipe and closed pipe have same length. The ratio of pith overtone of two pipes. Open pipe and closed pipe having same length. L1 is LC is equal L0 is equal to L, LC is equal to L. Both are having same length. The ratio of pith overtone of two pipes. So fundamental frequency of a open pipe F0 is equal to V by 2 L0. For closed pipe FC is equal to V by 4 LC. So a pith overtone means F0 is equal to P plus 1 into V by 2 L0. Here pith overtone. Except fundamental is nothing but overtone. So here FC is equal to 2P plus 1 into V by 4 LC. Okay, pith overtone of open pipe, pith overtone of closed pipe. So that is equal to, this can be considered 1, this can be considered 2. So F1 by F2 is equal to P plus 1 into V by 2L0 divided by 2P plus 1 into V by 4LC. So V we get cancelled. So here L0 is equal to L, LC is equal to L. These two are cancelled. Here 2 times cancelled. So that is equal to 2 times of P plus 1 divided by 2P plus 1. This is the ratio of pith overtone of a open pipe and closed. Okay students. Next, question number 11. Question number 11. See. The natural frequency of a tuning fork P is 432. This is the one of the tuning fork, that is P. Natural frequency is 432 hertz. 3 beats are produced when tuning fork P and another tuning fork Q are sounded together. Another tuning fork Q. So this is the known frequency, this is the unknown frequency. Both are sounded together, number of bits is 3. Delta n is equal to 3. If P is loaded with wax, the number of bits increases to 5 bits. So delta n dash is equal to 5 bits. When the number here, if P is loaded with wax, that means certain mass is added to P. Certain mass is added to P. So when mass is increases, moment of inertia is also increases. So then frequency is decreases. When frequency is decreases, but actual number of bits is given increases. Okay, so we know that bit frequency f1 minus f2 is equal to delta n or delta f. Otherwise, you can take this is np minus nq is equal to delta n. So here one is unknown frequency, another one is known frequency. So both are sounded together. The number of bits is obtained 3. Sometimes 3 is increases, 3 is decreases. So 432 plus 3 is 435 edges. 433 minus 3 is 429 edges. Either this one or this one is correct answer. Okay. So here what happens? P tuning fork is added to wax. Wax added means mass is increases, moment of inertia is also increases, frequency will be decreases. So now frequency will be decreases means I should consider decreasing frequency is 1. So that is 432 minus 1 is 431. This 431 is sounded with 435, 429. So 431 minus 435 is 4 number of bits. 431 minus 429 is 2 number of bits. So which one is obtained? More number, increasing number of bits. 4 is the increases. 4 is the increases. So that answer is 435. Bits is increases here compared to initial. Initial is 3, final is 5. So that's why 431 is sounded with 435, number of bits is 4. 431 is sounded with 429, number of bits is 2. So this is the decreases, this is the increases. If it is given increases means answer is this one. Any question like this. Suppose unknown is wax cell. Here like mass increases, moment of inertia, frequency decreases, one can be decreases. Suppose filing. Any question is given. Okay, answer is 435 edges. Okay. Next question number 12. See. A tuning fork produces 6 beats per second with a sonometer Y when its tensions are either 169, T1 is equal to 169 newtons, T2 is equal to 196 newtons. The frequency of that fork is how much? The frequency of that fork is how much? This frequency is how much? Okay. So we know that according to fundamental laws of a structural string, so n is equal to 1 by 12 into under root of t by v. So n is directly proportional to root t. So L and mu are constant. So n1 by n2 is equal to under root of t1 by t2. So n1 by n2 is equal to under root of 169 by 196. That is equal to 13 by 14. Here n2 is equal to 14 by 13 n1. So here n2 is greater than 1, greater than n, greater than n1. So that means n2 minus n1 is equal to, we don't know original tuning for n2 minus n is equal to 6, n minus n1 is equal to 6. We are doing calculation. n2 minus n1 is equal to 12. n2 minus n1 is equal to 12. So here n2 is equal to 14 by 13 n1 minus n1 is equal to 12. So n1 is equal to 12 into 13. So n1 is equal to 12 into 13 is 156 edges. So here we know that n minus n1 is equal to 6. So n is equal to n1 plus 6. So n is equal to 156 plus 6. So n is equal to 162 edges. N is equal to 162 edges. The frequency of that fork is 162 edges. Okay students, like this you are doing the problem. Next question number 13. See, the speed at which a source of sound should move so that a stationary observer finds the apparent frequency equal to 11 by 12 of the original frequency. Stationary observer. That means the speed of the observer is 0. The speed at which source of sound should move a stationary observer. So this is the source moving with velocity vs towards the observer. So the apparent frequency f dash is equal to 11 by 12 times of f. But here is not given any direction is moving. This is vs. So here apparent frequency is less than original frequency. So that's why the source is moving away from the observer. The source is moving away from the observer. So here apparent frequency f dash is equal, velocity of sound is always taken source to observer. So v by v minus v plus vs into f. Here f dash by f is equal to v by v plus vs. From this f dash by f is equal to how much? 11 by 12. So 11 by 12 is equal to v by v plus vs. So do the cross multiplication. So 11v plus 11vs is equal to 12. So 11vs is equal to 12v minus 11v. So 11vs is equal to v. So vs is equal to v by 11. So velocity of the source v is equal to 1 by 11 of velocity of the sound. But the source is moving away from the observer. Away from the observer. Source is moving towards the observer or away from the observer. Velocity of sound is always taken source to observer. Okay. Next question number 14. Question number 14. See. An engine is moving on a circular path of radius 100 meters. An engine is moving on a circular path of radius 100 meters with a speed of 20 meters per second. The frequency observed by a observer standing stationary at the center of a circular path when the engine blows a whistle of frequency 500 Hz. So an engine is moving on a circular path of radius is how much? 100 meters. Engine is nothing but source. Moving with velocity is how much? 20 meters per second. The frequency observed by an observer standing stationary at the center of the circular path. A man is standing here. His velocity is a 0. When the engine blows a whistle of frequency, Fs is equal to 500 Hz. So you can ask the question, the frequency observed by the observer standing stationary at the center of a circular path. So here any component of the source is perpendicular to observer. So here a source and observer are perpendicular. There is no Doppler effect. So not applicable for, in this case, no Doppler effect. Doppler effect is not applicable. In this case, Doppler effect is not Doppler effect is not applicable because source and observer are perpendicular. So that's why apparent frequency is equal to frequency produced by a source. So that's why apparent frequency is equal to how much frequency produced by a source? 500 Hz. That is the answer. Okay? Either here or here or here or here at any point. Always perpendicular to observer. Source is always perpendicular to observer. Okay? Next question number 15. An observer moves towards a stationary source of sound with velocity 1/5 of the velocity of sound. The percentage increasing in apparent frequency is how much? So here source is at rest. So Vs is equal to 0. So observer is moves towards the stationary. This is here observer moving with velocity V0 towards the stationary. So velocity of sound is always taken source to observer. Here how much velocity the observer is moving towards the stationary? V0 is equal to V by 5. 1/5 of velocity of the sound. The percentages increase in the apparent frequency is how much? Now we can write down apparent frequency f dash is equal to V plus V0 by V into F. Because of here velocity of sound and observer both are in opposite direction can be taken as first. Observer source is at rest. So f dash is equal to V plus V naught by 5, V by 5 divided by V into F. So F dash is equal to 5, we take LCM, 5V plus V by 5V into F. So F dash is equal to 6V by 5V into F. V get cancelled, that is equal to 6 by 5 F. So here F dash by F is equal to 6 by 5. So you should find out percentage means F dash by F minus 1 into 100 is equal to, so 6 by 5 into minus 1 into 100. So this is the percentage, that is equal to 6 minus 5 by 5 into 100. So that is equal to 1 by 5 into 100. So that is equal to, so how much percentage? The percentage increase in apparent frequency is 20. Okay na? So 41 is the second option, 20. Okay? Okay, see it. So here observer is moving with velocity 1/5 of velocity of sound towards the source, but the source is at rest. So apparent frequency F dash is equal to V plus V naught by V into F, because here both are in a opposite direction, can be taken as a positive. So substitute F dash, here F dash is equal to V plus V naught is nothing but V by 5 by V into F. So do the calculation, that is equal to F dash by F is equal to 6 by 5. You can ask percentage means final value minus initial value by initial value into 100. So here F dash minus F1 minus 1 is both side removed. Minus 1. So 6 by 5 by 5 into 100, that is equal to 1 by 5 into 100, that is equal to 20%. The percentage increase in apparent frequency is 20. Okay students? Next question number 16. A vehicle with a horn of frequency is moving with velocity of 30 meters per second in a direction perpendicular to the line joining the observer and the vehicle. The observer perceives the sound to have a frequency n plus n1. If the velocity of sound in air is 300 meters per second, so then n1 is equal to how much in terms of n? Okay? See. So the vehicle with the horn of frequency n, nothing but source. Vehicle is nothing but called horn of frequency n. Horn of frequency n. Moving with a speed of Vs is equal to 30 meters per second. In a direction perpendicular to the straight line joining the observer and vehicle. So here observer. So this is the direction of, otherwise here you can take observer. Both are perpendicular. See. A vehicle with a horn of frequency n moving with a velocity 30 in a direction perpendicular to the line joining the observer and vehicle. Here observer, both are perpendicular. Otherwise, here it is observer. So this is the direction of, this is the perpendicular distance. The observer perceives the sound to have a frequency. So f dash is equal to n plus n1. So the observer perceives the sound to have a frequency n plus n1. If the velocity of sound in air v is equal to 300 meter per second. So here you should find out n1 is equal to, first option n1 is equal to 10n, n1 is equal 0, n1 is equal to 0.1n, n1 is equal to minus 0.1n. So here it is perpendicular means so Doppler effect is not applicable. That means so f dash is equal to n, apparent frequency is equal to original frequency because of not applicable for Doppler effect. Not applicable for Doppler because of source and observer are perpendicular. So n dash is f dash is equal to n. So in this case n1 is equal to how much? 0. So that is equal to, so f dash is equal to n. So apparent frequency is nothing but a original frequency produced by a source. Okay. Okay students, this is complete object different models based on waves. Thank you very much.